Have you ever wondered if a small whisper could trigger a storm on the other side of the world? Imagine a butterfly flapping its wings in a Brazilian jungle, setting off a cascade of air molecules that ultimately leads to a tornado in Texas. It sounds like a plot from a fantasy novel, yet it encapsulates a real-world scientific inquiry known as the butterfly effect. This concept is not just about butterflies or weather, it's a dramatic illustration of chaos theory. Chaos theory explores how tiny variations in the initial conditions of a dynamic system can lead to vastly different outcomes. The flapping wings represent a minute change in the atmospheric conditions, but under chaos theory, such minute changes can influence weather patterns on a global scale. By understanding the butterfly effect, we delve into a world where the predictable becomes unpredictable, and where the minute actions of individuals can ripple through systems, creating significant impacts. This is the essence of the butterfly effect, a fascinating phenomenon rooted in the heart of chaos theory. To understand the butterfly effect, first, we must dive into the complex world of chaos theory. Imagine chaos not as total disorder, but as an intricate pattern of cause and effect, woven into the fabric of the universe, where the slightest variation can alter the whole tapestry. Chaos theory is a branch of mathematics and physics that studies how even tiny differences in a dynamic system's initial conditions can yield wildly diverging outcomes, rendering long-term prediction almost impossible. This sensitivity is known as deterministic chaos, or simply chaos. Think of a bustling city traffic system. Each vehicle, pedestrian, and signal interacts in such a way that a single car slowing down could eventually cause a traffic jam miles away. Or consider the weather. A system so complex that the precise starting conditions must be known to an impossible degree to accurately predict weather changes more than a week away. The roots of chaos theory date back to the late 19th century, but it was Edward Lorenz, a meteorologist, who brought it into the public eye in the 1960s. Lorenz discovered, through a computer model simulating weather patterns, that rounding numbers to a slightly different decimal place could drastically change the course of his simulated weather. This led Lorenz to propose that similarly small changes in the atmosphere could ultimately account for drastic weather events, a phenomenon famously illustrated by the metaphor of a butterfly's wings causing a typhoon halfway across the world. Thus, in chaotic systems, a tiny difference in initial conditions can lead to vastly different outcomes. This idea challenges our classical notions of predictability and control, showing that in nature, as in human endeavors, some outcomes might forever elude our grasp, not due to randomness, but because of the intricate interdependence of all things within a dynamic system. What makes these systems so sensitive to initial conditions? This question brings us to the heart of what we call the butterfly effect, a fascinating concept within chaos theory. Let's delve into the science behind this sensitivity and uncover how minute changes can lead to vast, often unforeseen consequences. At its core, the butterfly effect is about how small variations in the initial conditions of a dynamic system can have profound impacts on its long-term behavior. This is known as sensitive dependence on initial conditions. To understand this, imagine a complex system, be it weather patterns, financial markets, or even a simple double pendulum. Each of these systems follows deterministic laws, yet they exhibit unpredictable behaviors. Why does this happen? It starts with the systems themselves, which are non-linear. In non-linear systems, outputs are not directly proportional to inputs. A small input in such a system can trigger a response vastly disproportionate to the initial action. This non-linearity is a crucial ingredient for the butterfly effect. Now, consider how this plays out in weather systems, a classic example of chaos theory in action. Weather is governed by nonlinear equations where small differences in input, like atmospheric pressure or temperature, can transform a sunny day into a stormy one. This unpredictability makes long-term weather forecasting a monumental challenge. The butterfly effect also illustrates the limits of predictability in these systems. Even with the most sophisticated technology, the exact replication of initial conditions is virtually impossible, leading to divergent outcomes. This inherent unpredictability is not a flaw of the models, but a fundamental characteristic of chaotic systems. In practice, this means that tiny, seemingly insignificant factors can and do lead to dramatic changes. The flutter of a butterfly's wings represents these small changes, metaphorically suggesting how minor perturbations can escalate into significant, unpredictable results. It's this sensitivity that allows a butterfly flapping its wings in Brazil to potentially affect weather patterns in Texas. How did scientists first come to recognize this bewildering effect? The story begins in the early 1960s with a meteorologist named Edward Lorenz. While working on weather prediction models at the Massachusetts Institute of Technology, Lorenz made a serendipitous discovery that would later become known as the butterfly effect. During his experiments, Lorenz entered slightly different initial conditions into his computer program, simulating weather patterns. To his astonishment, these minute changes produced wildly different outcomes. This led him to propose that weather is highly sensitive to initial conditions, a cornerstone of what is now known as chaos theory. This concept of sensitive dependence on initial conditions doesn't just apply to weather. Let's consider the stock market, a complex system influenced by a myriad of factors, both big and small. Minor news items or unexpected financial reports can sometimes cause significant market swings, illustrating the butterfly effect in economics. These fluctuations can cascade, affecting economies worldwide in ways that are unpredictable and profoundly complex. Another compelling example is found in environmental science. Take the deforestation of a small area in a vast forest, which might seem inconsequential. However, this act can disrupt local ecosystems, leading to unforeseen consequences like altered weather patterns or the extinction of species, which in turn affect global biodiversity and climate. In the realm of technology, consider the impact of a single software bug. In 2003, a software bug in the northeastern United States led to a blackout, affecting over 50 million people. A minor glitch in a complex system resulted in massive power outages, demonstrating how small technological errors can lead to colossal consequences. These examples show how the butterfly effect plays a crucial role in various fields, reshaping our understanding of predictability and causality. From meteorology to economics, environmental science to technology, the butterfly effect reminds us that in a connected world, the smallest changes can have the largest impacts. Beyond academic theories, how does the butterfly effect influence our daily lives? Imagine you're deciding whether to drive your car or take public transportation to work. This choice might seem small, but in the context of the butterfly effect, its repercussions can ripple through traffic patterns, urban air quality, and even influence city planning decisions over time. Each decision we make, no matter how minute, has the potential to set off a chain of events beyond our immediate perception. In the realm of environmental conservation, the butterfly effect is particularly poignant. A community choosing to adopt renewable energy sources, for instance, doesn't just reduce their own carbon footprint. It contributes to a larger trend that might encourage energy companies to shift towards more sustainable practices, which could eventually influence global energy policies. This cascading series of events shows how localized actions can have global impacts. Turning to the business world, companies often use the principles behind the butterfly effect to strategize their moves. A tech company might decide to invest in a small innovative startup. This seemingly modest investment could lead to the development of breakthrough technologies that redefine market standards and consumer expectations, illustrating how small financial inputs can lead to substantial economic transformations. On a more personal level, consider how everyday interactions and decisions shape our lives. A simple act of kindness, like complimenting a colleague, can boost their morale, improving teamwork and productivity. Or consider personal investments in education or health, which not only enhance individual quality of life, but can also influence broader societal norms and expectations over generations. Understanding the butterfly effect empowers us to see the weight of our actions, not just in the immediate outcomes, but in the extended web of potential consequences. It teaches us the importance of foresight and consideration in everything we do, from the mundane to the monumental. Recognizing the power of small actions can lead us to make more thoughtful decisions in our complex world. Embrace the unpredictable, for it is the fabric of our existence. As we've journeyed through the intricacies of chaos theory and the butterfly effect, we've uncovered a world where tiny variations can lead to profound changes. From the flutter of a butterfly's wings, possibly influencing weather patterns across the globe, to minor changes in initial conditions that can alter the course of human history, this concept has shown us the interconnectedness of all things. Understanding the butterfly effect isn't just about scientific curiosity, it's about gaining a deeper appreciation for the complexity and unpredictability of the world around us. It teaches us to expect the unexpected and to see the potential in the smallest of actions. It encourages us to think critically about the outcomes of our actions, embracing a mindset that is both cautious and adventurous. As we navigate through life's chaos, this knowledge arms us with the wisdom to influence and adapt to the ever-changing tapestry of our environment. So, the next time you witness a butterfly in motion, remember the profound impact of small beginnings. Who knows what storms your own actions may stir?